So today we're going to be looking at the distance and midpoint formulas. The supplies that you're going to need are graph paper, and you're going to need a few pages, a ruler or some kind of straight edge, and pencil and or pen. So the first thing I need you to do is to draw a coordinate plane on a piece of graph paper. And let's go ahead and fill the page for now. So on your coordinate plane, I'd like you to plot 2 points. The first point is point A, and it is located at 1, 2, and point B is at 5, 2. And then we're going to connect the 2 points using a ruler. So feel free to pause the video anytime you need more time to do whatever the drawing is asked of you. Okay? So the question is, how far apart are points A and B? Well, because they are on the same horizontal line, they have the same y value. So if we look at the difference between the two x's, that will give us the length of that line. And here, 5 minus 1 is equal to 4. So it's 4 units from A to B. And you can count that as 1, 2, 3, 4 spaces. Now let's do the same thing with points C and D. Point C is located at -4, -2, and point D is at -4, +3. So you're going to plot those 2 points, and then you will connect them with your ruler. So again, our question is going to be, how far apart are they? Well, this time, because they're on the same vertical line, they have the same x value because they moved the same amount of space to the left when you started plotting them. So if we find the difference in the y values, that would give us the distance between them. So the difference between 5 and -2 would, or I'm sorry, 3 and -2 would be 3 minus -2, which is 5. And if you were to count the spaces, 1, 2, 3, 4, 5, they are 5 apart. So what if we wanted to find the distance between 2 points that were not on either a horizontal or vertical line, but on a diagonal? Let's plot 2 points, F at -1, -6, and G at 6, -3. Go ahead and draw a line from point F to point G using your ruler. Now you may have noticed that I added another point here. I'm adding a point so that the diagonal that we just drew really becomes the hypotenuse of a right triangle. So now if I do that, I can, let's say I'm going to call this point H, and it would be, it's on the same vertical line as point G, and it's on the same horizontal line as point F, so its point would be 6, -6. Now we can draw a right triangle by completing the triangle attaching point F to point G to point H. So now we have a right triangle, and we know how to find the hypotenuse of a right triangle, so we can use the Pythagorean theorem to help us. So let's go ahead and label the lengths that we know. So from G to H is 3 units. I'll even call them units. And that would be the difference between our y values. And if we look at the difference in our x values, we go from -1 to +6, which would be 7 units. So now, if we wanted to find the length between the distance between F and G, we could apply the Pythagorean theorem of a squared plus b squared equals c squared. So if a is 3, squaring that would give us 9. If b is 7, squaring that would give us 49. 9 and 49 would give us 58. So 58 is the value of c squared. So we take the square root of both sides of this equation, and we have the square root of 58. which I don't believe can be simplified. But if we were to put that in a calculator, we could approximate it. Let's just do that. So the square root of 58 is approximately 7 6/10, which makes sense because it is greater than 7 units and obviously greater than 3 units. So there is a formula that if you want to memorize, you can, called the distance formula. And it says that the distance between any two points on a coordinate plane can be found by taking, so whatever x2 and y2 are, they belong to the same pair, the same ordered pair, right? They're the same point. x1 and y1 would also be one point. That if you take the difference in the x's and square it, and add it to the difference of the y's and square it, I don't know if you can see my square there, and then you take the square root of the whole thing, you get the distance formula. Well, isn't that what we just did? On this problem, we took, in order to find this value, well, let me just, you put this into the equation. So we're finding the distance between this point and this point, okay? So the distance formula says if we take the difference in the x's squared plus the difference in the y's squared and take the square root of the whole thing, we get the distance between them. So let's take the x's. I'm going to use this point as the xy2. This is going to be the xy1. Okay, so the square root of the x is 6 minus this x of -1, which is like +1, right? Squared plus this -3 minus -6 would be like -3 plus 6, which would be -3 plus 6 is +3 squared, so that's +9. This is 6 plus 1 squared, which is 49. The square root of 49 plus 9, which is what we did over here, but we just thought about it a little differently, as if it were the Pythagorean theorem. So go ahead and plot these 2 points on a coordinate plane, and let's find the distance between them. So I plotted the 2 points. Now, you can see it's a diagonal, so I need to form a right triangle. And I could do it any way I wanted, just as long as this is the hypotenuse. I think I'll do it this way. Oops. So now this length is 2, this length is 3, and I could calculate it if I wanted to using the ordered pairs, or I could just count it because it's all in the same quadrant. So the length of this would be the sum of 2 squared plus 3 squared. So that's 4 plus 9 is equal to 13, and that gives us the value of c squared. That means c is equal to the square root of 13. Now, if we go back to the formula using these 2 ordered pairs, we would take the difference in the x's, and so I'm just going to do this. 1 minus 3, so I'm going to take the square root of this to get the distance. 1 minus 3 is -2 squared gives us 4, and then -5 minus -2 would be -5 plus 2, which would be -3 squared gives us 9, square root of 13. Same thing. Right, just taking a formula approach versus a drawing and understanding of the Pythagorean theorem approach. Okay, on another coordinate plane, I'd like you to plot these points. So point A is -2, +2. Point B is 3, 4. Point D is -3, -2. And point C is 3, -3. Go ahead and pause the video if you need to so you can get that done. Okay, once that's done, you're going to connect them in ABC order to form a quadrilateral. So our objective on this quadrilateral is to find its perimeter. That means we want to know the distance around the outside of the figure. So drawing right triangles here for each of these might work, although we don't need it for this side. We can see that this is a vertical line, so we could just find the difference in the y values to get that length. These other lengths, though, you probably want to apply the distance formula to make it simpler. So if you again want to pause the video and give it a try and then come back. Okay, well, these measurements were not very friendly. You probably noticed that. So although this one was easy to see, it was 7 units. If you apply the distance formula between points D and C, you should have gotten the square root of 37. Between A and D is the square root of 17, and between A and B is the square root of 29. So in order to find the perimeter, we would have to add up those values, and of course at this point you would want to use a calculator. So I rounded them to the 10th place, and these are the 4 lengths that add up to about 22 6/10 units. Okay, the next thing we need to talk about is midpoint. And midpoint is exactly what it sounds like. It is the middle of 2 points. So say we had point A and point D. The midpoint would be, let's say, point B here, so that this distance would be equal to this distance. So in order to find the midpoint of these 2 points, we need to add the x values and divide that by 2, and then add the y values and divide by 2. So we have a x of -3 and y of 5. -3 plus 5 is +2 divided by 2 would give us 1. And then -1 plus 2 gives us +1 divided by 2 is 1/2. That means that 1/2 is the midpoint. And you can see visually it looks like that is the midpoint. So I know that was a lot to take in. So make sure you, when you're working on the practice, if you need to go back and watch the video again, you can. Double check your notes. You can also look at the lesson in the book. Okay, good luck.